In the unending silent theatre of the cosmos, where the script is written in gravity and light, and the actors are stars and worlds, stories unfold over timescales that mock human comprehension. Imagine a traveler, not one of flesh and blood, but of ice and dust, a primordial shard from a solar system that may no longer exist. For billions of years, this traveler has journeyed through the absolute desolation of interstellar space, the cavernous void between the stars. It has sailed through the ghostly filaments of nebulae, regions where new suns were screaming into existence, and it has drifted past the cold, dark embers of stars that died long before our own sun had even coalesced from its natal cloud. This pilgrim of the void was a time capsule, a silent witness to galactic history, carrying within its frozen heart the chemical fingerprints of its long-lost home. Its journey was a testament to endurance, a study in resilience against the most profound and unforgiving environment imaginable, the interstellar medium. Here, the temperature hovers just a few degrees above absolute zero, a cold so deep it can shatter the very bonds of matter. It was bombarded by high-energy cosmic rays, relentless particles accelerated to near light speed by distant supernovae, each impact a microscopic explosion that could have compromised its integrity. It weathered the subtle but persistent pressure of stellar winds from a million different sources. It navigated the faint, ghostly gravitational tides of star clusters and the colossal, unseen grip of dark matter. Through all of this, for a span of time that makes the entire history of human civilization seem like the briefest flicker of a candle, it held together, it persisted. It was a monument to the durability of cosmic matter, a tiny dark speck moving with purpose through an ocean of nothingness. Its path was a perfect, silent hyperbola, a trajectory that screamed of alien origins, a path not bound to our sun, but one that was merely passing through, a tourist on the grandest of scales. Then, after a journey of perhaps 1 billion years, it entered our solar system. It crossed the heliopause, the boundary where the sun's solar wind gives way to the interstellar medium, and for the first time it felt the direct influence of a new star, our star. It was no longer a traveler in the great void, but an intruder in a settled kingdom of planets. As it continued its inexorable fall towards the heart of our system, it passed the orbits of the ice giants Neptune and Uranus, their distant blue glows too faint to have any meaningful effect. It passed Saturn, the ringed jewel, and then the colossal king of our system, Jupiter. With every passing moment, the sun grew from a bright, distant star into a blazing, dominant disk of light and energy. And as it drew closer, this ancient, hardened traveler began to awaken. The faintest warmth, a mere whisper of solar radiation, began to stir the volatile ices that had been frozen solid for eons. It began to sublimate, to transform directly from solid ice into gas, and a faint, tenuous atmosphere, a coma, began to form around its nucleus. Astronomers on a tiny blue planet, our planet, took notice. They saw a point of light moving against the backdrop of fixed stars, a point of light that was steadily, promisingly growing brighter. It was a visitor, an emissary from the great beyond, and it carried the promise of a spectacular show. Predictions were made, excitement grew. This was to be a celestial event for the ages, a beacon in the night sky. But then, the paradox began. The very thing that was bringing it to life was also its executioner. The closer it came to the sun, the more brilliantly it shone, but this brilliance was not the steady glow of a healthy, stable object. It was a feverish, frantic outgassing, the last desperate exhalation of a dying entity. After surviving the unimaginable rigors of interstellar space for 1 billion years, a journey of silent, stoic fortitude, it began to crumble in a matter of weeks. The light, the very source of its magnificent awakening, became the hammer that shattered it. The point of light did not just brighten, it fluctuated, it sputtered, and then, most unnervingly, it began to fade. The traveler that had endured the deep cold and the chaotic violence of the galaxy was being undone by the gentle warmth of a star. The celestial celebrity in the making was dying before its grand premiere. The great paradox was laid bare for us to witness. It existed for 1 billion years in the dark, only to perish within days of reaching the light. And this raises the most profound and unsettling question. What force, what inherent flaw could possibly make a survivor of the galactic wilderness so fragile? What could possibly destroy such an ancient, hardened cosmic traveler, not in the brutal emptiness between the stars, but in the relative safety and warmth of a planetary system. What secret did it carry within its heart that made the suns embrace a fatal one? To give a name to a thing is to begin to understand it, or so we believe. On Earth, we named this traveler C divided by 2019 Y4, Atlas, a designation as sterile and functional as a laboratory instrument. The C marked it as a comet, a long-period wanderer. 2019 Y4 was its birth certificate, a timestamp marking the moment our electronic eyes first registered its presence in the fourth half of December 2019. And Atlas was the name of its discoverer, not a single person, but a sentinel, the asteroid terrestrial, impact last alert system, a pair of robotic telescopes in Hawaii designed to scan the sky for objects that might pose a threat to our world. But this object was no threat. It was a gift. And its true name, the one that would place it in the Celestial Hall of Fame, was far more profound. 3I divided by Atlas. The I stands for Interstellar. It was only the third object in all of human history to be given this designation. It was a certified, card-carrying alien, a visitor from another star. Before 3I divided by Atlas, there were two others who had blazed this trail, each one fundamentally reshaping our understanding of our place in the galaxy. For all of recorded history, we had studied what we believed to be a closed system. The planets, the asteroids, the comets of our solar system were our family, a cosmic clan bound by the gravity of a single parent star. We knew them, we catalogued their orbits, we understood their chemistries. We believed we lived on a celestial island, isolated by an impassable ocean of interstellar space. That illusion was shattered in 2017 with the arrival of one I, Oumuamua. The name is Hawaiian, meaning scout, or first distant messenger, and it was aptly chosen. Oumuamua was nothing like we expected. It was small, dark, reddish, and tumbling chaotically through space. Most bizarrely, it had no visible coma, no gaseous halo that would classify it as a comet. Yet, it was accelerating away from the sun faster than gravity alone could explain. Something was pushing it, some invisible force that baffled scientists. Was it outgassing unseen molecules? Was it made of some exotic material, like a pure hydrogen or nitrogen iceberg, that would be invisible to our telescopes? The most radical theories even posited it could be an artifact, a piece of alien technology, a solar sail tumbling out of control. Oumuamua was a complete enigma. It asked more questions than it answered, and was gone before we could even properly aim our best instruments at it. It was a fleeting, ghostly whisper from the beyond. Then, just 2 years later, came 2I, divided by Borisov. Discovered by an amateur astronomer, Gennady Borisov, this object was a welcome relief to many scientists. It looked normal. It was unmistakably a comet. It had a large, bright coma and a distinct tail. As it got closer to the sun, we analyzed the light passing through its atmosphere and found its chemical composition to be remarkably similar to the comets from our own solar system. It contained cyanide, diatomic carbon, and water, the familiar building blocks. Borisov was the second messenger, and its message was one of cosmic mediocrity, the idea that the processes that formed our solar system are likely common throughout the galaxy. It suggested that comets everywhere are probably made of the same stuff. It was a comforting, if less exciting, discovery. And so the stage was set. We had one complete weirdo and one seemingly normal cousin. What would the third visitor be? This is where 3I divided by Atlas enters the story. Its trajectory was the first clue. Like its predecessors, it was tracing a sharp, open-ended hyperbola through our solar system. It wasn't in a closed elliptical orbit like our planets and comets, forever bound to the sun. It was moving far too fast. It had screamed in from the direction of the constellation Ursa Major, and it was destined to swing around the sun and be flung back out into the void, never to return. The math was unequivocal. This object did not belong to us. Its origin was elsewhere, in the deep, unplumbed darkness between the stars. But what made 3I divided by Atlas truly unique, what secured its place in history, was not its origin, nor was it its initial appearance. It was its ultimate fate. Oumuamua was the mystery we never got to solve. Borisov was the familiar traveler who passed by without incident. 3I divided by Atlas, however, was the tragedy we witnessed in high definition. It was the only interstellar visitor whose death we have ever recorded. While the others were mere passers-by, Atlas became a specimen for an unprecedented cosmic autopsy. We didn't just observe its journey, we observed its complete and utter disintegration. This singular event, its spectacular and unexpected demise, elevated it from a mere astronomical curiosity to a Rosetta Stone for understanding the nature of these alien wanderers. Its death was not a failure of a great celestial show. Its death was the show, providing a firework display of data that revealed more about its alien nature than a simple, intact flyby ever could. It was a messenger that died delivering its message, and in its final, shattering moments, it told us that the universe beyond our home is far more complex, fragile, and strange than we had ever dared to imagine. In science, a failed prediction is often more valuable than a successful one, for it signals a gap in our knowledge, an invitation to a deeper mystery. But for the human heart, for the collective imagination of a world watching the skies, a broken promise can feel like a genuine loss. And in the early months of 2020, Comet 3I divided by Atlas made a promise of spectacular proportions. The world at that time was grappling with a growing unease. A global pandemic was beginning to cast its long shadow, and people were looking for a distraction, a sign of wonder, a reminder of a universe larger than our immediate troubles. Atlas seemed poised to be that celestial balm. The initial data was not just promising, it was electrifying. From the moment of its discovery, the comet was brightening at a truly astonishing rate. In the world of cometary science, predicting the future brightness of a comet is a notoriously tricky business, often likened to predicting the behavior of a cat. But there are models, mathematical curves based on how the sublimation of ice should increase as the comet gets closer to the sunday. Atlas wasn't just following the curve for a potentially great comet, it was shattering it. Its brightness was increasing exponentially, a rocket-like ascent that, if extrapolated forward, led to a breathtaking conclusion. By the time it was scheduled to make its closest approach to the Sun in late May 2020, it would be, by some of the more optimistic predictions, one of the brightest objects in the night sky. The whispers began to build into a roar in the astronomical community and among amateur skywatchers. This could be it. This could be the one we've been waiting for. The term Comet of the Century began to be tentatively floated. We were told to prepare for a spectacle not seen in decades, perhaps since the magnificent Hale-Bopp in 1997. The vision was intoxicating. A brilliant, star-like head, easily visible to the naked eye even from light-polluted cities. And streaming from it, a majestic tail of dust and gas, a luminous ribbon of ethereal light stretching across a significant portion of the sky, a silent, ghostly banner hanging in the twilight. Some models even predicted it could become as bright as the planet Venus, perhaps even visible in broad daylight, the rarest and most awe-inspiring of all celestial events. It was a perfect story. An alien visitor, a traveler from another star, arrives in our solar system and puts on the greatest celestial show of a generation as a gift to a troubled world. It was a narrative of cosmic hope, of a universe capable of producing profound beauty and wonder, delivered right to our doorstep. We were not just observers, we were the chosen audience for this one-time performance. The anticipation was a palpable force. Telescopes, both amateur and professional, turned their gaze towards this single brightening point of light. The anticipation was the emotional peak, a crescendo of human expectation focused on a single tiny frozen rock billions of kilometers away. And then the music stopped. In late March, the rocket-like ascent in brightness faltered. It didn't just slow down, it hit a plateau. For a few days, the astronomical community held its breath. Perhaps it was a temporary lull, a brief pause before an even more dramatic outburst. Comets are unpredictable after all. But the pause stretched into a week, and the news grew more worrying. The comet wasn't just stalling, it was starting to fade. The hope began to curdle into confusion, and then came the images. High-resolution photographs from observatories around the world began to show that the comet's core, its central condensation of light, was no longer a sharp, star-like point. It had become fuzzy, elongated. It looked unwell. The promise was not just broken, it was shattering. The dream of a great comet, the beacon of hope in a dark time, was disintegrating before our very eyes. The sense of loss was surprisingly profound. This wasn't merely a failed astronomical prediction, it felt like a cosmic betrayal. We had been promised a symphony of light and were left with a mournful silence. The spectacular show was cancelled. The star performer had died. This emotional gut punch, this transition from unbridled hope to stark disappointment, is precisely what makes the story of 3, I Divided by Atlas so compelling. The failure of the prediction became the real story. Why did it happen? Why would an object that seemed so vibrant, so energetic, so full of potential, suddenly and catastrophically fall apart? We had mistaken a fever for a sign of strength. We had interpreted a death rattle as a roar of defiance. The very data that fueled our grand predictions was in fact evidence not of its impending glory, but of its fatal inherent flaw. The mystery was no longer if we would see a great show, but why this ancient interstellar pilgrim, this survivor of the galactic void, had traveled for 1 billion years only to die under our sun at the very moment we had all gathered to watch. The heartbreaking mystery was just beginning. Before we can truly grasp the profound strangeness of 3I, Divided by Atlas, we must first establish a baseline. We must journey into our own cosmic backyard and understand the nature of the celestial nomads we call our own. To understand the exception, we must first intimately know the rule. The objects we call comets are, in their essence, the most pristine relics from the dawn of our solar system. They are the leftover building materials, the frozen scraps that were never incorporated into the grand architecture of the planets. For 4.5 billion years, the vast majority of them have existed in a state of suspended animation, locked in the profound cold of the solar system's outermost frontiers, a vast spherical reservoir called the Oort cloud, and a flatter, more orderly disk beyond Neptune called the Kuiper belt. There, in the silent, near absolute zero darkness, they drift like ghosts, their internal clocks frozen at the moment of creation. We often refer to them by the charmingly simple moniker, dirty snowballs, and while accurate, this phrase belies their true complexity and significance. The snow in this recipe is not just the frozen water we know on Earth. It is a cocktail of ices, substances that would be gases here but are frozen solid in the deep cold of space. Water ice, H2O, is almost always the dominant ingredient, the structural backbone of the entire object. It's the cement that binds everything else together. Mixed in with this foundational water ice are other, more volatile ices. Carbon dioxide, CO2, what we know as dry ice, carbon monoxide, co-methane, TH4, and ammonia, NH3. The dirt is a collection of cosmic dust, tiny silicate mineral grains, like microscopic grains of sand, and a complex mix of carbon-based organic molecules, tholins, which give the cometary nucleus a surface that is often one of the darkest materials in the solar system, blacker than asphalt. Imagine this object, the nucleus, as a porous, irregularly shaped mountain of frozen slush and gravel, ranging from a few hundred meters to tens of kilometers across. For eons, it is inert, lifeless, indistinguishable from a common asteroid except for its hidden, frozen heart. Its story begins when a subtle gravitational nudge, perhaps the passing of a nearby star or a tidal disturbance within the galaxy, disrupts its stable, distant orbit. This tiny push is enough to send it on a new path, a long, slow fall towards the inner solar system, towards the Sunday. As it crosses the orbit of Neptune, then Uranus, then Saturn, little changes. The Sun is still just the brightest star in the sky, its warmth too feeble to stir the deeply frozen ices. But as it journeys inward, past the orbit of Jupiter, it approaches a critical, invisible boundary in space, a region astronomers call the frost line. This is the point at which the sun's radiation becomes intense enough to begin awakening the ancient ices. And this is where the magic begins. The process is not melting. In the perfect vacuum of space, liquids are unstable. Instead, the ice undergoes sublimation. It transitions directly from a solid into a gas, just as a block of dry ice produces a thick vapor on a warm day. This outgassing is the engine of a comet. It's the force that transforms an inert rock into one of the most dynamic and beautiful spectacles in the heavens. The first gas to awaken is typically the most volatile, like carbon monoxide. But the true show begins when the most abundant ice, water, starts to sublimate. The escaping gas doesn't just seep out gently. It erupts from the nucleus in powerful jets and geysers, blasting away from fissures and weak spots on the surface. These jets carry with them the dust and dirt that was trapped within the ice. This mixture of liberated gas and dust expands outwards, forming a vast, tenuous atmosphere around the nucleus. This is the coma. While the nucleus itself may be only a few kilometers wide, the coma can swell to an astonishing size, often becoming larger than the planet Jupiter, sometimes even larger than the Sun itself. It is this glowing, gaseous shroud that we see from Earth as the bright, fuzzy head of the comet. But the transformation is not yet complete. The Sun's influence now reveals itself in two distinct and powerful ways, creating the comet's most iconic feature, its tail. Or more accurately, its two tails. The first is the ion tail, or gas tail. The Sun constantly emits a stream of charged particles called the solar wind, which flows outwards at hundreds of kilometers per second. This solar wind interacts with the gases of the coma, and its ultraviolet radiation is powerful enough to ionize them, stripping electrons from their atoms and giving them a net positive charge. These newly created ions are now electrically susceptible to the magnetic field embedded within the solar wind, which sweeps them up and pushes them directly away from the Sun, like smoke caught in a powerful gale. The ion tail therefore always points directly away from the Sun, regardless of the comet's direction of travel. It often glows with a ghostly blue light, the signature color of fluorescing carbon monoxide ions. The second tail is the dust tail. The dust particles released from the nucleus are much heavier and are not affected by the solar wind's magnetic field. Instead, they are pushed by a much gentler but persistent force, the pressure of sunlight itself. Photons of light, while massless, carry momentum, and the collective push of trillions upon trillions of photons striking these tiny dust grains is enough to nudge them away from the Sunday. Because the dust particles are more massive and are left to trail behind the comet in its orbit, this tail is often broad, diffuse, and noticeably curved. It shines with a soft, yellowish-white light, which is simply reflected sunlight bouncing off the countless tiny grains of dust. This entire process, the sublimation of water ice driving the formation of a coma and two distinct tails, is the standard model. It is the accepted, well-understood physics of a normal comet from our own solar system. Its activity is predictable. We know that the water ice engine will really turn on somewhere between the orbits of Mars and Jupiter. We know that its brightness should increase according to a fairly standard mathematical formula as it gets closer to the Sun and receives more energy. We know its life cycle. It will make its pass around the Sun, blazing in glory for a few short months, and then, as it recedes back into the outer solar system, the engine will shut down. The coma will dissipate, the tails will fade, and it will once again become a dormant, frozen nucleus, slightly smaller and lighter than before, having shed a tiny fraction of its mass. This is the baseline. This is the state of normal. It is a water-driven, predictable, and familiar phenomenon. We built our entire understanding of cometary science on this foundation, observing thousands of these domestic visitors over centuries. And so, when we first saw 3I divided by Atlas, we naturally applied this same rulebook. We saw it brightening, and we applied the standard formula. We saw a visitor from afar, and we assumed it was built to the same specifications as our local comets. This was our framework, our lens for viewing the universe. And it was this very foundation of knowledge that made the subsequent behavior of 3I divided by Atlas so utterly confounding, because this interstellar traveler was about to demonstrate, in the most catastrophic way imaginable, that it was not written with the same set of rules. It was a fundamentally different kind of beast. The comets of our solar system are homebodies. They are members of our celestial family, bound by the invisible but unbreakable leash of the Sun's gravity. Their paths are ellipses, closed loops that, while sometimes vast and taking millennia to complete, are ultimately predictable paths of return. They leave, but they always come back. They are part of a repeating, cyclical story. 3I divided by Atlas was singing a different song entirely. Its trajectory was not the gentle, returning curve of an ellipse. It was the sharp, definitive slash of a hyperbola. In the language of orbital mechanics, a hyperbola is not a path of return. It is a path of escape. It is the signature of an object carrying too much energy, moving with too much velocity, to ever be captured by our Sun's gravitational embrace. It was a cosmic cannonball fired from another star system, destined to treat our sun not as a destination, but as a temporary gravitational slalom pole before being flung back out into the interstellar darkness from whence it came. This single geometric fact, this open-ended curve, was its irrefutable passport, stamped with the seal of a foreign star. It certified its identity as a true interstellar wanderer. And with that certification comes a profound and staggering realization of the journey it must have endured. It was an ancient nomad. Let us try for a moment to truly contemplate the nature of that journey. Our own solar system is a sanctuary, a cosmic oasis of relative order and warmth in the midst of an unthinkably vast and hostile desert. The space between the stars, the interstellar medium, is an environment of extremes that makes the harshest conditions on Earth seem like a gentle summer's day. For millions, perhaps billions of years, 3I divided by Atlas called this void its home. The first and most dominant feature of this environment is the cold. A cold so absolute it is difficult for the human mind to process, hovering at just a few degrees above absolute zero, the theoretical point at which all atomic motion ceases. In this profound freeze, chemical reactions slow to a near standstill. The very concept of weather or change becomes meaningless. This stasis is a double-edged sword. It is a perfect preservative, locking the comet's primordial composition in place, turning it into a pristine time capsule from its birth solar system. But it is also a force that makes things brittle, that could turn any internal stress or flaw into a catastrophic fracture with the slightest disturbance. But the interstellar medium is not empty. It is filled with a constant, invisible rain of high-energy particles known as cosmic rays. These are the nuclei of atoms, primarily protons, that have been accelerated to near the speed of light by some of the most violent events in the universe: exploding stars, or supernovae, and the churning accretion disks around supermassive black holes. For eons, 3I divided by Atlas flew through this relentless galaxy-wide radiation storm. Every second it was being peppered by microscopic bullets, each one carrying the kinetic energy of a fastball. This constant bombardment should have fundamentally altered its very nature. Scientific theory predicts that over millions of years this process of irradiation would work a kind of cosmic alchemy on its surface. The simple ices and organic molecules would be broken apart, their atoms rearranged and cross-linked into a complex, tough, and inert web of larger, more durable molecules. It should have formed a crust, a protective mantle several meters thick, a hardened shield baked and cured by the radiation of the galaxy. This crust would be dark, non-reflective, and, most importantly, structurally robust. It would also serve to seal in the more volatile ices buried deep within the nucleus, protecting them from the rigors of space. And it wasn't just cosmic rays. It was the subtle but persistent gravitational harassment of the galaxy itself. As it traveled, it would have felt the ghostly tidal caress of passing stars, the gentle stretching and squeezing from drifting through giant molecular clouds, and the overarching colossal pull of the Milky Way's galactic core. Each of these encounters would have been a small test of its structural integrity, a cosmic stress test that should have weeded out the weak. Any loosely bound material should have been stripped away long ago, leaving behind a solid, compacted, and durable core. To survive this gauntlet is to be proven strong. The journey itself was a process of natural selection on a cosmic scale. Only the toughest, most resilient objects could possibly endure such a marathon. Therefore, the logical assumption, the one based on everything we knew about physics and the interstellar environment, was that 3I divided by Atlas must be an extraordinarily tough and resilient object. It should be a hardened veteran, a cosmic survivor clad in radiation-baked armor. Here, the story shifts from pure science to a kind of philosophical poetry. Imagine this ancient nomad on its silent pilgrimage. It has witnessed the birth of new stars and the death of old ones. It carries the chemical memory of a stellar nursery that may have dissipated billions of years ago. It has traveled further than our species has any right to comprehend. It is older than the mountains on Earth, perhaps older than life on Earth itself. It is a physical piece of another world, another history, delivered to our doorstep. As this grizzled traveler finally crossed the threshold into our solar system, it was entering what should have been a far more benign environment. The warmth of our sun, compared to the constant sleet of high-energy cosmic rays, should have been a gentle spring thaw after a billion-year ice age. The shield that had protected it from the ravages of the galaxy should have been more than sufficient to handle a little bit of sunlight. Everything about its past screamed resilience. Everything about its journey implied an inherent toughness that bordered on indestructibility. We looked at this interstellar pilgrim, and we saw a mountain. We expected it to behave like one. And that is precisely why its subsequent catastrophic failure was not just a surprise, but a deep, paradoxical shock to our most fundamental assumptions about how the universe works. The ancient nomad had survived the wilderness, only to inexplicably collapse upon reaching the warmth of the campfire. For every celestial object, there is a rhythm, an expected cadence of behavior dictated by the unyielding laws of physics. For a comet from our own solar system, that rhythm is a slow, predictable crescendo. It is a piece of music that begins in silence in the outer dark, builds gradually as it crosses the orbit of the giants, and only truly finds its voice, its full orchestral power, when it nears the warmth of the inner solar system. The engine of this orchestra, as we've established, is overwhelmingly driven by the sublimation of water ice. And water, in the near vacuum of space, requires a certain threshold of energy, a specific proximity to the sun, to begin to truly sing. This threshold lies roughly within the orbit of Jupiter. So, when we watched the ancient nomad, 3I divided by Atlas, make its grand entrance, our expectations were set by this familiar rhythm. We anticipated a period of quietude, a slow awakening. We were prepared for the overture, not a sudden explosive blast of sound. Yet, that is precisely what we got. The first omens, the first dissonant notes in this cosmic symphony, were detected while Atlas was still in the frozen suburbs of our solar system. As it journeyed inward, approaching the colossal domain of Jupiter at a distance of more than 500 million kilometers from the Sun, it should have been a faint, almost entirely dormant object. At this range, the Sun's light is a pale imitation of its power, its warmth a mere whisper, insufficient to vigorously sublimate the vast stores of water ice that form the structural core of a typical comet. But 3I divided by Atlas was already stirring. It was already shrouded in a significant coma, a ghostly halo of gas and dust that belied the immense cold. It was active. It was awake. And this was deeply, fundamentally wrong. This premature activity was the first clue, the first subtle but unnerving piece of evidence that this interstellar visitor was not playing by our rulebook. It was like seeing a desert flower bloom in the middle of a polar winter. It defied the known environment. This was the first premonition, the first hint that its internal composition was radically different from our own comets. Something far more volatile than water ice had to be powering this display. Some substance that treated the faint, distant sunlight near Jupiter as a scorching inferno, a chemical that viewed this profound cold as a balmy spring day. This early activity was initially a source of great excitement. It was this very overperformance that fueled the grand predictions of a comet of the century. Its rapid, almost violent brightening at such a great distance was extrapolated forward, leading to the logical, yet ultimately flawed, conclusion that it would be an object of unprecedented brilliance. When it finally reached the sun's full glare, we saw this unusual vigor and we interpreted it as a sign of immense power, of a vast reservoir of frozen material ready to be unleashed. In hindsight, our interpretation was a tragic failure of imagination. We mistook a raging fever for a sign of robust health. This premature outgassing wasn't a show of strength. It was a symptom of a fatal, congenital weakness. It was the first sign that the very architecture of the comet was unstable. These were the seeds of its own destruction, sprouting long before it ever felt the true heat of the Sunday. The very process that was making it so dazzlingly bright was the same process that was tearing it apart from the inside out. Imagine a steam engine built from poorly riveted, brittle metal. The moment it begins to build a head of steam, long before it reaches its operational pressure, you hear the ominous creaks and groans of metal under strain. You see the seams beginning to bulge. The engine's early power is not a promise of performance, but a warning of imminent, catastrophic failure. This is what we were witnessing with 3I divided by Atlas. Its early brilliant activity was the sound of its internal structure beginning to fracture under a pressure it was never designed to withstand. The connection between this premature activity and its eventual complete disintegration is direct and inescapable. This was not a healthy object that was suddenly and unexpectedly killed by the Sunday. This was a terminally ill patient, an object with a pre-existing condition, whose demise was merely accelerated and made visible by its approach to our star. The great paradox of its billion-year journey culminating in a days-long death was beginning to resolve itself. It didn't die because it reached our solar system. It had arrived dying, and we were simply privileged to have a front-row seat for its final spectacular moments. This early, anomalous glow was not a beacon of a coming spectacle. It was the slow-motion flash of a demolition charge that had been armed for 1 billion years, and its timer had just been started. In the grand, silent courtroom of the cosmos, evidence is not gathered from witnesses but from the faint whispers of light. To understand the true nature of a distant object, to uncover its secrets, astronomers become forensic scientists. Their primary tool is the spectrograph, an instrument that acts like a cosmic prism, taking the faint, blended light from a comet's coma and breaking it down into its constituent colors, its fundamental rainbow of wavelengths. Woven into this spectrum are dark or bright lines, a unique barcode imprinted by the chemical elements and molecules that are present in the gas. Each molecule, water, ammonia, cyanide, absorbs and emits light at a very specific, unchanging set of frequencies. This pattern is its fingerprint, an unmistakable signature that allows us to identify it from across hundreds of millions of kilometers. When we turned our spectrographs towards the familiar comets of our own solar system, we had always found a consistent story. The chemical fingerprint was overwhelmingly dominated by one key signature, that of the hydroxyl radical, OH, a direct chemical descendant of broken-down water, H2O, molecules. Water is the lifeblood of our comets. Its signature is the bold, unambiguous title on the cover page of their chemical story. The other signatures, carbon dioxide, carbon monoxide, and so on, are present, but they are the footnotes, the minor characters in a narrative dominated by H2O. So, as 3I divided by Atlas began its premature, anomalous brightening, the world's great observatories raced to capture its light, to read its chemical barcode, and to find the engine driving its unusual activity. The initial results trickled in, and then they poured in, and they all pointed to a conclusion so radical it was almost unbelievable. The dominant fingerprint was not water. In the spectrum of 3I divided by Atlas, the bold, screaming signature belonged to carbon. Specifically, the data revealed an immense abundance of molecules containing carbon, which strongly suggested the comet was venting enormous quantities of carbon monoxide, CO, and even more significantly, carbon dioxide, CO2. When the final calculations were done, the ratio of these volatile carbon ices to water ice was found to be enormous, far exceeding that of a typical solar system comet. This wasn't just a minor variation, it was a fundamental, architectural difference. It was like examining the bones of a creature you thought was a mammal and finding they were made not of calcium but of silicon. This was its alien nature, written in the language of chemistry. To understand the profound implications of this discovery, we must understand the nature of CO2. We know it on Earth as dry ice. It is a substance of fascinating properties. Most critically, it does not require much energy to sublimate. While water ice needs the relatively balmy temperatures found inside the orbit of Mars to truly begin to fizz, dry ice will turn directly into a gas at a staggeringly cold -78.5 degrees Celsius, -109.3 degrees Fahrenheit. It is a super volatile substance. To put it into perspective, the environment near Jupiter, which is a deep freeze for water, is a scorching heat wave for carbon dioxide. This single piece of data, this strange chemical fingerprint, was the key that unlocked the first part of the mystery. It was the answer to why Atlas was active so early. It wasn't that the comet was unusually powerful, it was that its fuse was incredibly short. It was made of a substance so volatile, so eager to turn into gas, that the faintest, most distant caress of sunlight was enough to set it off. The engine driving its magnificent early display wasn't the steady, reliable burn of water ice, the hardwood log of cometary fuel. It was the explosive, almost uncontrollable flash ignition of dry ice, the gasoline vapor of the cosmos. This chemical data does more than just solve one puzzle. It deepens the central tragedy of the story. The very ingredient that made 3I divided by Atlas so special, so brilliantly active in the outer solar system, was also the source of its inherent fragility. A comet whose structure is dominated and held together by water ice is like a fortress built of granite. It's tough, resilient, and requires significant energy to break down. But a comet whose structure is dominated by frozen carbon dioxide is like a palace carved from a block of frozen dynamite. Its very substance is a source of explosive, disruptive power. The discovery of this bizarre chemical fingerprint transformed our understanding of the comet. It was no longer a simple, dirty snowball. It was a cosmic pressure vessel, a cryogenic bomb that had been ticking silently for 1 billion years. The seeds of destruction we had glimpsed in its early activity now had a name, and that name was carbon dioxide. We now knew the what. We had found the motive for its self-destruction. The next question was how. How could this super-volatile ingredient lead to such a complete and catastrophic failure? The evidence for that would soon become shockingly, visually apparent. In the architecture of our solar system, there is one undisputed king, a celestial monarch of such staggering proportions that it almost constitutes a solar system in miniature. That king is Jupiter. It is a leviathan, a world so vast that all the other planets, Saturn, Uranus, Neptune, Mars, Venus, Mercury, and our own Earth could comfortably fit inside it with room to spare. Its diameter stretches over 140,000 kilometers. It is a benchmark of cosmic scale, the yardstick against which we measure all other planetary bodies. To be Jovian is to be colossal. The nucleus of a comet, by contrast, is an object of almost comical insignificance. The icy heart of 3I divided by Atlas was estimated to be, at most, a few kilometers across the size of a small town or a modest mountain on Earth. It is a grain of sand next to the beach ball of Jupiter. And yet, in the final, feverish weeks of its life, this tiny interstellar grain of sand produced an atmosphere that dwarfed the king. This was the next piece of evidence. And it was not a subtle chemical line in a spectrum, but a spectacle of sheer, unbelievable scale. As the runaway sublimation of its internal carbon dioxide ice began to accelerate, the coma of 3I divided by Atlas didn't just grow. It inflated, it swelled, it erupted outwards into the vacuum of space with astonishing speed. And then, for a few brief, breathtaking days in March 2020, this tiny, fragile visitor achieved something that defies all earthly intuition, something that borders on the absurd. Its gaseous atmosphere, its coma, grew to be larger than the planet Jupiter. Pause for a moment and allow the sheer insanity of that visual to take hold. Imagine the colossal striped giant with its great red spot, a storm larger than our entire planet, churning in its atmosphere. Now, superimpose upon that image a ghostly, ethereal bubble of gas and dust, a gossamer sphere that not only matches the planet in size, but actually engulfs and surpasses it. At its peak, the coma of Atlas was estimated to have expanded to a diameter of roughly 720,000 kilometers. This was an atmosphere generated by a nucleus that was, relative to that coma, the size of a single microscopic dust mote floating in the middle of a vast concert hall. This was not a sign of power. This was the visual evidence of a complete and total hemorrhage. The runaway outgassing of the super volatile CO2 was no longer a controlled process of jets and vents. The internal pressure had become so great that the very structure of the nucleus was failing. It was visibly dissolving, turning itself inside out and casting its own substance into the void. This colossal, Jovian-sized ghost was the comet's final, silent scream. It was the last glorious spectacle before the end. The nucleus, the tiny engine at the heart of this display, could no longer contain the forces it had unleashed. The palace of frozen dynamite was not just cracking. It was liquefying, vaporizing, and expanding into a phantom of its former self. We were witnessing the bloat that precedes the burst. And the most powerful eye humanity has ever built was about to turn and stare directly into the heart of this fading ghost, to capture the precise moment it fractured into 1,000 pieces. Scientific theories and indirect evidence are one thing, a photograph is another. A photograph is truth. It is a moment frozen in time, a piece of reality captured and held for all to see. In astronomy, the ultimate arbiter of truth, the final, unblinking eye that can settle debates and reveal the universe in its most raw and glorious detail, is the Hubble Space Telescope. For 3 decades, it has drifted in the silent vacuum above our world, its gaze fixed on the cosmos, delivering images that have not only redefined science, but have become icons of our culture. And in April of 2020, as the ghost of 3I divided by Atlas continued to fade from the view of ground-based telescopes, mission controllers aimed this legendary instrument directly at the heart of the fading smudge. They were not just observing the comet, they were performing a celestial autopsy from a distance of over 140 million kilometers. The images that Hubble sent back were both heartbreaking and scientifically electrifying. They were the undeniable proof, the smoking gun. 3I divided by Atlas was not just dying, it was already dead. Its body was in pieces. The first images taken on April 20th were staggering. Where there should have been a single, albeit fuzzy, point of light, the comet's nucleus there was instead a scattered, elongated train of debris. The ancient nomad had been shattered. Hubble's razor-sharp vision resolved the single dying ember into more than 30 distinct, separate fragments. The second set of images, taken just 3 days later on April 23rd, revealed a scene of even greater chaos. The fragments had drifted further apart, and some of them had visibly faded or even vanished entirely, suggesting they too were continuing to break down into even smaller pieces. This was not a single, clean break. It was a progressive, cascading failure, a complete structural collapse. The team of astronomers who analyzed the images described the fragments as being incredibly small on a cosmic scale, with some pieces estimated to be no larger than an average house. Think about that for a moment. An object that had survived for 1 billion years in the brutal wilderness of interstellar space, a cosmic mountain of ice and rock, had been reduced to a collection of celestial houses, floating silently in the dark. This was evidence of the most visceral and irrefutable kind. It was a series of photographs of the corpse. The Hubble images allowed scientists to watch the disintegration in near real time, to measure the speed at which the pieces were separating, and to observe their individual fading. The fragments were not blasted apart in a violent explosion as one might imagine. Instead, they seemed to be drifting apart lethargically, with the speed of a slow walk. This gentle separation was another crucial clue. It suggested that the force that broke the comet apart was not a powerful external blow, but a gentle, pervasive, and internal process. The palace of dynamite hadn't been hit by a wrecking ball. It had simply crumbled under its own internal pressure, its walls giving way with a final, exhausted sigh. The credibility of the Hubble Space Telescope is absolute. Its data is the gold standard. When Hubble sees something, it is real. These images ended all speculation about the fate of 3I divided by Atlas. The promise of a great spectacle was officially over, replaced by a far more profound and scientifically valuable event, the first ever high-resolution observation of the complete disruption of an interstellar comet. We had traded a beautiful, fleeting piece of cosmic theater for a priceless scientific artifact. We had lost a show, but we had gained a Rosetta Stone. The evidence was now on the table. The premature activity, the bizarre chemical fingerprint, the impossibly large coma, and now the photographic proof of its utter destruction. The what had been established beyond a shadow of a doubt. It was time for the final act in this scientific detective story, to explain the why. It was time to build the theories that could connect all these disparate pieces of shocking evidence into a single, coherent narrative of its death. In the quest to solve any great mystery, the first step is always to examine the most straightforward, the most logical, the most mundane explanation. Before we leap to conclusions of alien engines or cosmic explosions, we must first ask a simpler question. What if it was just poorly made? This is the first and most fundamental hypothesis for the death of 3I divided by Atlas. It is the theory of inherent fragility. It posits that the comet did not die because of some spectacular, violent process, but simply because it was a visitor from a different kind of celestial neighborhood, built to different specifications, and it was simply not designed to survive the conditions of our own. It was a beautiful, intricate snowflake that flew too close to the fire. The foundation of this idea lies in its alien origin. The comets of our solar system were all born from the same protoplanetary disk, a swirling cloud of gas and dust that shared a common chemical recipe. This recipe included not just ices, but a significant amount of silicate dust and rocky material, the dirt in the dirty snowball. This dust acts as a crucial binding agent, a kind of cosmic rebar that gives our comets a degree of structural integrity and strength. But who is to say that the star system from which 3I divided by Atlas was born shared that same recipe? It is entirely plausible, even likely, that it formed in a region of its home nebula that was relatively dust-poor. Imagine a comet that is almost pure ice, perhaps with a more porous, fluffy consistency. It would be less a dirty snowball, and more of a cosmic snow angel, ethereally beautiful, but incredibly delicate. It would lack the internal reinforcement that makes our own comets comparatively tough. It would be a structure built of frozen foam rather than frozen concrete. Furthermore, we must reconsider the effects of its billion-year journey. While we theorize that this ordeal should have hardened it, it's equally possible it had the opposite effect. The relentless bombardment by cosmic rays may not have formed a uniform, protective shield, but instead a brittle, eggshell-thin crust over a volatile interior. The constant, subtle gravitational stretching and squeezing from passing stars and nebulae may not have compacted its core, but instead introduced a web of microscopic fractures and stress points throughout its structure. It may have arrived not as a hardened veteran, but as an ancient piece of glass riddled with invisible cracks, just waiting for the right stress to be applied. And upon entering our solar system, that stress came in two powerful, relentless forms. The first was thermal shock. As Atlas drew closer to the Sun, the side facing our star began to heat up rapidly, causing it to expand. Meanwhile, its other side, facing the cold of deep space, remained frozen solid. This stark temperature differential across its small body would create immense internal tension. For a robust object, this is manageable. For our fragile, pre-cracked visitor, this constant expansion and contraction would have been torturous, causing the microfractures to deepen and spread, connecting with one another until the entire nucleus was structurally compromised. The second force was the Sun's gravity itself, manifesting as tidal forces. This is a gentle but inescapable cosmic torture rack. The Sun's gravitational pull is not uniform across an object. It pulls more strongly on the side of the comet that is closer to it than the side that is farther away. This creates a differential, a stretching force that constantly tries to pull the object apart. For a massive, solid planet, this effect is negligible. But for a small, weakly bound, fluffy ball of ice, this persistent, gentle stretching could have been the final, fatal blow. It would have worked its way into the existing cracks, slowly and inexorably prying the comet apart, not with a bang, but with a quiet, final surrender. This hypothesis is compelling because of its simplicity, and it aligns perfectly with the evidence from Hubble. The lazy, slow drift of the fragments is exactly what you would expect from an object that simply fell apart under gentle, continuous stress, rather than being blown apart by a single violent event. In this scenario, there is no villain. The Sun was not a murderer. It was just being a star. 3I divided by Atlas was not a victim. It was just an object in the wrong place at the wrong time. It was a visitor unaccustomed to our local customs of heat and gravity. This is the baseline theory, the logical, scientific, and objective starting point. It is the idea that our interstellar guest was simply too delicate, too ethereal for our world, a ghost from a gentler place that simply faded away when exposed to the harsh light of our reality. The first hypothesis, that of a simple, fragile structure, is elegant in its logic. It is a story of passive surrender. But there is another, more audacious, more violent, and perhaps more compelling narrative that fits the evidence not just well, but perfectly. This is the hypothesis that 3I divided by Atlas was not a passive victim of the Sun's forces, but an active participant in its own demise. It suggests that the comet was a cosmic pressure cooker, a self-destructing engine, and that its death was not a gentle crumbling, but a spectacular, internally driven suicide. The very element that made it unique, its vast reservoir of super-volatile carbon dioxide, was not just a fuel source, but the very mechanism of its own destruction. To understand this theory, we must move away from the image of a simple snowball, and instead envision the comet's nucleus as a complex geological engine. For billions of years, as it drifted through the interstellar cold, its entire structure was in a state of perfect, frozen equilibrium. The immense stores of frozen CO2 were locked deep within its porous, icy matrix, as stable and inert as the rock around them. But as it entered our solar system and began to feel the first faint warmth of the sun, that equilibrium was shattered. The sublimation process began, not just on the surface, but deep within the comet's heart. Sunlight, even from as far away as Jupiter, can penetrate several meters into a porous cometary nucleus. This gentle warming radiation began to awaken the CO2 not from the top down, but from the inside out. Pockets of frozen dry ice, trapped for eons, began to transform directly into high-pressure gas. Now, consider the shell. Its billion-year journey through the cosmic ray storm may have created a hardened, less porous outer crust. This crust, which we once thought of as a protective shield, now becomes the cap on a pressure vessel. It prevents the newly formed gas from escaping freely into space. So, with every passing moment, the pressure inside the comet began to build. Millions of tiny, isolated pockets of sublimating CO2 began to exert a relentless, expanding force on the surrounding icy structures. The comet's very core was turning against itself. It was becoming a steam engine with no release valve, a cryogenic bomb where the ticking was the steady, inexorable rise in temperature. This internal pressure would not necessarily need to be explosive in the way we imagine a bomb on Earth. The tensile strength of porous, non-compacted ice is incredibly low. The pressure would only need to build to a point where it could overcome the weak, frozen bonds holding the nucleus together. It would start with microscopic fractures, which would then propagate and connect as the gas forced its way through any available weakness. The nucleus would begin to split apart from within, not with a single violent bang, but with a series of deep internal ruptures. This perfectly explains the comet's final, feverish burst of activity. The period just before its disintegration, when its coma swelled to a size larger than Jupiter, can be reinterpreted not as a sign of healthy outgassing, but as the moment the pressure vessel finally breached its containment. The internal fractures had reached the surface, and the vast quantities of trapped high-pressure CO2 gas erupted into space in a single, catastrophic venting event. This massive, sudden release of its internal atmosphere would have inflated the coma to its absurd Jovian proportions in a very short period. It was the comet's last, great exhalation. And most critically, this hypothesis provides the single most elegant explanation for the evidence captured by the Hubble Space Telescope. Why were the fragments drifting apart so slowly, so lazily? Because they weren't propelled by an external force. They were gently pushed apart by the expansion of the residual gas trapped between them. Imagine breaking a piece of bread. You don't throw the two halves apart. You pull, and they gently separate. The expanding CO2 gas acted like a gentle, irresistible force, nudging the newly formed fragments away from each other at the pace of a slow walk. This gentle explosion is the cornerstone of the self-destruction hypothesis. It is a perfect match for the visual evidence. In this telling of the story, 3I divided by Atlas becomes a far more tragic and dynamic character. It was not a victim of our Sunday. It was a victim of its own exotic, alien physiology. It carried the seeds of its own destruction within its heart for its entire billion-year journey. Its unique chemical makeup, its very identity, was also its fatal flaw. The sun was not the executioner. It was merely the catalyst, the trigger that armed the bomb and started the final countdown. The death of 3I divided by Atlas, in this view, was the inevitable, spectacular, and predestined outcome of its own unique and volatile nature. It was an alien that simply could not survive in our environment, not because it was weak, but because it was dangerously, powerfully, and fatally different. The two preceding hypotheses share a common, elegant thread. They assume that 3I divided by Atlas died because of what it was. Its story was one of inherent nature, of a fatal flaw written into its very chemical composition or its fundamental structure from the moment of its birth. In these narratives, the comet was a tragedy waiting for a stage, a character whose final act was preordained by its own internal constitution. But there is a third door we must open, a path that leads into a realm of pure, informed speculation, a hypothesis that is both more extraordinary and, in some ways, more representative of the true, violent nature of the cosmos. This is the theory of the ancient wound. It posits that the fatal flaw of 3I divided by Atlas was not what it was, but what happened to it, long before it ever felt the warmth of our Sunday. It suggests that our interstellar guest did not arrive as a pristine, fragile artifact, but as a wounded survivor, carrying a mortal injury hidden deep within its frozen heart for 1 million or 1 billion years. To embrace this idea, we must first humble ourselves before the staggering ignorance we have of the comet's history. We witnessed, in exquisite detail, the last few weeks of its multi-billion-year lifespan. This is the cosmic equivalent of reading the final sentence of a 10,000-page epic novel and then attempting to divine the entire plot. Its journey through the interstellar void is a complete and total black box, a history without witnesses. We speak of this journey as a long, quiet drift through an empty cold, but this is a comforting simplification. The interstellar medium is not a tranquil ocean. It is a wilderness, filled with unseen hazards and punctuated by moments of extreme, localized violence. And it is in this great unseen, in that billion-year gap in its life story, that our comet may have suffered the injury that would ultimately seal its fate. Let us imagine one possible scenario, a high-velocity, microscopic impact. As Atlas sailed through the darkness, it may have crossed paths with a stray piece of interstellar shrapnel, a tiny grain of rock, perhaps no larger than a pebble, ejected from another solar system. In the context of Earth, such an impact would be meaningless. But in space, velocity is everything. The relative speeds between objects drifting in the galaxy can be immense, tens or even hundreds of kilometers per second. At such speeds, that tiny pebble would not simply chip the comet's surface. It would strike with the focused energy of a high-explosive shell. The impact itself would be instantaneous, but it would send a catastrophic shockwave propagating through the comet's entire porous, icy body. This shockwave would not be enough to shatter it completely. The comet, after all, survived to reach us. But it could have created a vast, deep internal fracture, a critical weakness cleaving through its very core. Then, in the unimaginable cold of deep space, the raw, exposed surfaces of this new internal canyon would have been cold-welded shut, sealed by the slow refreezing of more volatile ices like carbon monoxide or nitrogen. The wound would have been hidden, latent, a ghostly scar buried deep beneath a seemingly intact surface. The comet would have continued its journey, looking for all the world like a whole and healthy object, but it would have been living on borrowed time. It was now a ticking time bomb, not of chemistry, but of structural mechanics. Or, consider another, even grander possibility, a gravitational maelstrom. In its long journey, 3I divided by Atlas may have passed perilously close to another star, or perhaps even a more exotic and compact object, like a white dwarf or a wandering black hole. The tidal forces in such an encounter would be orders of magnitude more powerful than the gentle stretching it experienced from our own Sunday. It would have been a near-death experience, a moment of cosmic torture where the object was stretched and squeezed almost to its breaking point. It may have survived the encounter, flung away on a new trajectory, but it would have been fundamentally weakened, its internal structure irrevocably compromised, its core riddled with deep gravitational stress fractures. It would have been a survivor of a cosmic shipwreck, its hull breached and barely holding together. In either scenario, the comet that entered our solar system was a fundamentally different object from the one that began its journey. It was an imposter, a fragile entity, masquerading as a hardened survivor. Now, reimagine its final days in this new light. The sun's gentle warmth begins to penetrate its surface. The supervolatile carbon dioxide starts to sublimate. But this gas doesn't need to build up enough pressure to break a solid, healthy object. It only needs to find the pre-existing weaknesses, the ancient, hidden wound. The gas would preferentially seep into these old fractures, acting like a cosmic crowbar. The cold weld that held the wound shut for millions of years would have been the first thing to thaw and vaporize. The gentle, persistent pressure of the sublimating CO2 would have been more than enough to pry open the old injury. The final disintegration, then, was not a new event. It was the completion of an act of violence that occurred in the deep past, in a place and time we will never know. The sun was not the cause of death. It was merely the coroner that exposed the old, fatal wound for us to see. This hypothesis expands our imagination, forcing us to see every visitor from the void not as a pristine specimen, but as a character with a history, a past filled with untold stories of survival and violence. It is a profound and humbling reminder that what we can see is only ever the end of the story, and that the universe beyond our sight is infinitely more complex, chaotic, and mysterious than we can ever truly comprehend. And so, the detective story reaches its conclusion. We have followed the clues, examined the evidence, and constructed our theories. We have weighed the possibilities of a fragile constitution, a self-destructing engine, and an ancient hidden wound. We have used the full, formidable power of our scientific method to piece together the final, violent moments of a visitor from another star. But to stop here, to close the case file and simply catalogue 3I divided by Atlas as a fascinating but finished data point, would be to miss the entire point. It would be to read the coroner's report on the death of a king and to feel nothing of the fall of his kingdom, to understand nothing of the history he embodied. The story of this comet's death is not merely a scientific puzzle. It is a philosophical lesson, a cosmic memento mori delivered to our doorstep. It is an invitation to step back from our equations and our spectrographs, to stand in silent contemplation and to feel the profound and crushing humility of our own small place in this universe. Let us try, with the limited power of our human imagination, to truly grasp the timescale we have just witnessed. The journey of 3I divided by Atlas did not begin last year, or 1,000 years ago, or even 1,000,000 years ago. Its voyage through the interstellar dark likely began 1,000,000,000 years ago, perhaps more. Let us anchor ourselves in that abyss of time. 1,000,000,000 years ago, the Earth was an alien world. The continents we know today were fused into a single desolate supercontinent called Rodinia. The atmosphere was thin and hostile, with far more carbon dioxide and far less oxygen. The most complex life forms on the entire planet were rudimentary, single-celled organisms and perhaps the first simple multicellular algae floating in the primordial oceans. There were no plants on the land. There were no fish in the sea. There were no animals of any kind. The great saga of the dinosaurs was still hundreds of millions of years in the future. The very ground upon which our cities are built had not yet been formed. It was on this barren, embryonic Earth that the light from our sun, which would one day kill 3I divided by Atlas, shone down. And out there, in the unfathomable darkness, our tiny traveller was just beginning its journey. It sailed through the void as continents drifted and broke apart. It persisted as life on Earth performed its slow, miraculous, and violent dance of evolution. It held its form as the first creatures crawled from the sea onto the land, as the great fern forests rose and fell, as the age of reptiles came and went in a flash of fire from the sky. It journeyed on, a silent, frozen witness, as the first furry mammals scurried in the shadows, as the primates evolved, as the ancestors of humanity first learned to walk upright on the African savanna. The entire glorious and bloody tapestry of human history, the invention of the first stone tools, the discovery of fire, the painting of the first cave art, the rise and fall of every empire, the birth of every religion, the composition of every symphony, the writing of every book, all of it, every single human thought and deed occurred during the final, infinitesimal fraction of 1% of this object's journey. It was already in our cosmic neighborhood, a silent intruder in the final stages of its approach, when the first pyramids were built. It was nearing the end of its long fall towards the sun when Galileo first turned a telescope to the heavens. And then we saw it. A species that has existed for a mere cosmic second looked up and noticed a traveller that had been on the road for 1,000,000,000 years. And in the space of a few short weeks, a span of time so brief it is a statistical zero against the backdrop of its lifespan, we watched it die. We, who lived for a handful of decades, were the audience for the final, catastrophic end of an entity that had outlasted mountains. What does it mean to witness such a thing? It is a lesson in perspective so profound it borders on the spiritual. All of our worldly concerns, our ambitions, our conflicts, our triumphs, they are revealed for what they are, the fleeting parochial squabbles of a young species on a single tiny world. We are beings of immense importance to ourselves, and of utter, complete indifference to the cosmos at large. We could not have saved 3I divided by Atlas. We could not have intervened. We could do nothing but watch, record, and try to understand. Our most powerful technologies, like the Hubble Telescope, did not make us participants in the event. They simply gave us a better seat in the audience. We were utterly passive witnesses to a drama that did not know we existed, a drama written in the universal laws of physics, a play whose first act was set in a time before our planet had even evolved a creature with eyes to see it. This is the very essence of cosmic humility. It is the realization that we are not the masters of the universe, but rather a temporary, emergent consciousness that has, through a series of incredible evolutionary flukes, been granted the breathtaking privilege of being able to observe and comprehend it. We are the universe's way of knowing itself, but we are a fragile and ephemeral part of it. To watch the death of 3, I divided by Atlas, is to be reminded that the universe is constantly creating and destroying on scales that dwarf our comprehension. It is a quiet, powerful whisper that says, "You are small, your time is short, pay attention, be humble, be grateful for the brief moment you are allowed to witness the show." The death of this interstellar visitor was not a loss in the grand scheme of things. It was simply a transformation, a change of state. But for us, for the brief consciousness that watched, it was a profound and unforgettable lesson in our own mortality and our own magnificent, improbable, and humbling place in the grand, silent theater of the cosmos. In our human stories, death is an ending. It is a final, declarative period at the end of a sentence. We are accustomed to the narrative of a single, coherent life that begins, persists, and then ceases to be. When 3I divided by Atlas shattered into a collection of house-sized pieces of ice and dust, our terrestrial intuition tells us that it died. The single entity, the ancient nomad with a billion-year history, was no more. Its singular story had come to a close. But the universe does not operate on the logic of human narrative. In the cosmos, death is rarely an ending. It is almost always a transformation, a redistribution, a scattering of seeds. And this forces us to ask a more profound and poetic question. What if the destruction of 3, I divided by Atlas, was not its death, but its apotheosis? What if it was not the end of its message, but the multiplication of its messengers? Before the disintegration, there was one object, one singular time capsule from another star system. It carried within it the complete, pristine chemical recipe of its long-lost home. It was a single, sealed letter. But when it shattered, that letter was torn open, and its contents were scattered to the cosmic winds. The 30 or more fragments that Hubble witnessed, and the countless smaller, unseen pieces of dust and ice that now trail in their wake, are no longer a single entity. They are a fleet. Each piece, no matter how small, is a direct, physical continuation of the original object. Each fragment is a legitimate heir to its legacy, carrying the exact same alien chemical fingerprint, the high ratio of carbon dioxide, the unique blend of interstellar organics that made the parent body so extraordinary. The original ambassador is gone, but in its place now travels a convoy of envoys, a diaspora of silent witnesses. Their journey is not over. They did not stop or fall into the Sunday. They are still moving with immense velocity along that same inexorable hyperbolic trajectory that brought them here. Having swung around our star, they are now on their way out, a scattered shotgun blast of primordial material heading back into the interstellar void. They will leave our solar system and continue their journey, perhaps for another billion years, through the great dark wilderness. The story has fractured, but it has not ended. What was once a single voice is now a choir, singing its silent chemical song into the darkness. We must then reevaluate what we witnessed. Was it a death, or was it a kind of birth? An act of cosmic reproduction, asexual and violent, where one traveler sacrifices itself to create many. It is as if the comet fulfilled some strange predestined purpose upon arriving in our system, to break itself open and release the seeds it had carried for so long. This idea transforms the fragments from mere debris into something far more meaningful. They are the last will and testament of a dead star system, now copied and distributed for an eternal journey. They are messages in bottles, thrown not into an ocean of water, but into the ocean of the galaxy. Perhaps, in some impossibly distant future, in a time and place we can scarcely imagine, one of these tiny, house-sized fragments will wander into another nascent solar system. A future alien civilization on a planet that does not yet exist might detect this tiny messenger. They might analyze its light and find the same strange chemical signature we did. They would be reading a single, surviving sentence from the epic of 3I divided by Atlas, a story whose beginning and middle they will never know. They would hold in their instruments a physical piece of a star system that was in turn alien to us. In this way, the legacy of this traveler becomes a great, cosmic chain letter, a story passed from star to star, not by light or gravity, but by the physical transfer of its own broken body. 3I divided by Atlas is not truly dead. It has simply been translated. It has sacrificed its unity for multiplicity, its form for its function. Its function perhaps was always to be a messenger, and its final, shattering act in our sky was not a failure, but the ultimate delivery of that message. It is a haunting, beautiful, and deeply optimistic image. The thought of these tiny, silent fragments, these children of a cosmic tragedy, sailing onwards into the infinite dark, each one a tiny, frozen ghost carrying the memory of its home, a whisper of a world we will never know, now scattered and eternal. We end where we began, with the image of a fading point of light, a traveler that survived 1 billion years in the wilderness only to perish in the warmth of a star. We have journeyed through the entire arc of its story, from the promise of its arrival to the post-mortem of its disintegration. We have dissected its chemistry, modeled its physics, and contemplated the very meaning of its cosmic existence. And after all of this, we are left with one final, overarching, and profoundly important truth. The story of 3I divided by Atlas is the ultimate reminder that the universe is not required to conform to our expectations. It is a lesson in the boundless and sometimes violent diversity of the cosmos. For centuries, our understanding of the universe was, by necessity, profoundly parochial. We studied the worlds of our own solar system, the planets, asteroids, and comets that were born from the same spinning cloud of gas and dust as our own Earth. We developed our beautiful, elegant theories of planetary formation and cometary behavior based on this single, local data set. It was all we had. We built a comprehensive rulebook for how a solar system works, and it was a good rulebook. It explained our home with remarkable accuracy. But the arrival of these interstellar visitors, first the baffling Oumuamua, then the reassuringly familiar Borisov, and now the catastrophically fragile Atlas, has served as a powerful and necessary corrective. They have torn pages from our rulebook and forced us to start again. 3I divided by Atlas, in its spectacular death, has told us that the recipe for building a solar system is not universal. Out there, in the countless stellar nurseries scattered throughout the Milky Way, the ingredients can be different. Some systems may be rich in the dust and rock that make for sturdy water-ice comets like our own. Others, like the home system of Atlas, might be fundamentally different, perhaps forming objects where supervolatile ices like carbon dioxide are not a minor ingredient, but the primary structural component. This is not a trivial distinction. It means that the very physics that governs the life and death of a comet can be radically different from one star system to the next. The universe is not a single, homogeneous factory producing identical parts. It is a collection of infinite, idiosyncratic workshops, each one creating objects according to its own unique blueprint, its own local chemistry, its own physical laws. This realization should fill us with a sense of profound wonder and intellectual excitement. It means that for every rule we have established based on our own home, there are likely 1 million exceptions scattered throughout the galaxy. There may be worlds made of materials we have not yet imagined, governed by geological and atmospheric processes that would seem like magic to us. There may be comets and asteroids with chemistries so bizarre they would force us to rewrite our textbooks from the ground up. We assumed for a very long time that we lived on a typical island in a vast archipelago of similar islands. 3I divided by Atlas is the messenger from a distant shore who arrives in a boat made of a wood we have never seen, speaking a language we do not understand, telling us that our island is not the template for the world, but merely one unique variation among countless others. And so, the story of 3I divided by Atlas does not truly end. It simply opens 1,000 new doors, 1,000 new questions. Its fading light is not a sign of closure, but an illumination of our own ignorance. It is a challenge, a dare from the universe to look further, to question our assumptions, and to embrace the unknown. The next interstellar visitor that graces our skies will be another chapter in this grand, unfolding story. It too will carry the secrets of its lost home. It too will test our theories and expand our imagination. The death of 3I divided by Atlas was not a tragedy. It was a gift. It was a stark, beautiful, and unforgettable reminder that the most exciting thing in science is not finding the answers we expect, but discovering the questions we never even knew to ask. It reminds us that the universe beyond our comfortable home is not just stranger than we imagine, it is stranger than we can imagine, and our journey to understand it has only just begun.